So section 10.1 talks about limits, the numerical and graphical viewpoints. This is an introduction to the concept of derivative. And what we're going to do in this section is mainly provide intuition. So our ultimate goal is to provide more of an algebraic perspective. But the thing that you want to get from this section is understand the notation, understand the intuition behind everything, okay? So let's start by viewing the number line. We have a number line here. So we have our number line here, we have 0 marked. This arrow means approaches, okay? We read this x approaches 0 from the right. This is read as x approaches 0 from the right. Okay? So, in other words, you're approaching 0 from the right-hand side. That's what that means. Okay? What does this mean? How do you read it? Very good. X approaches 0 from the left. This is why we reserve this arrow whenever you're writing and providing mathematical justification. We tend to use equal when we mean equal instead of the arrows because it means approaches. Okay? So we say x approaches 0 from the left. This, so again, it means we're approaching 0, but from the left-hand side on the number line. That's what that means. Now we say this is read as the limit of f of x as x approaches a. This is read as the limit of f of x as x approaches a. It's read as the limit of f of x as x approaches a. So this definition or this notation is the lim. We say of f of x as x approaches a. Okay? Definition. Let f be a function such that f of x is defined for values of x arbitrarily close to but different from a. So it gets close and close to that value but not necessarily equal to it. Okay? If f of x approaches the number L as x approaches but is not equal to a, regardless from which side, we say the limit of f of x as x approaches a is L. The notation is this. We write limit of f of x as x approaches a equals L. Okay? So in other words, this means that we can make f of x as close to L as we like by choosing any x in the domain of f sufficiently close to but not equal to a on either side. Okay? So if you have a function, graphically, if you have your xy axis, you have a value a, and then you have a function, you might have something like this, okay? So in other words, what you see, let's call this L. So as you notice, as x gets closer and closer to a on either side, the function gets closer and closer to L. That's what this means graphically. That's what's happening. So as long as it gets close to it, it's approaching it, we say it's equal to L. It doesn't necessarily have to be equal to A there. Okay? All right. So another definition. If f of x fails to approach a single fixed number as x approaches a, then we say that f of x has no limit as x approaches a, or we say that the limit of f of x as x approaches a does not exist. Does not exist. And sometimes you'll see people write DNE for does not exist. Sometimes you'll see that. Okay? So example 1, I want us to find the limit as x approaches 1 of 2 plus x. So I've graphed 2 plus x here. It's the graph of x shifted up 2 units. As x approaches 1 on either side, what does your function approach? 3. So your answer here is 3. So you have two things happening at once, okay? One, you're paying attention to the x values, getting closer and closer to that value here, and you're paying attention to what your function is approaching. Does that make sense? Okay. So here, it's hard to determine this from the graph, but what do you think this is going to approach as x approaches 3? What do you think will be the limit of 1 over x as x approaches 3? 1/3. Very good. It's going to be 1/3. So what you're noticing is that it looks like you're able to do, it looks like you're able to substitute that value in someplace. Algebraically, that's what's happening, but intuitively, you're approaching the x value of 3 here, and you're examining what your function is getting close to there. Okay, so that's technically what's happening. Okay, the limit as x approaches 0 of 1 over x, what is that going to be? Does not exist. Very good. It does not exist. D and E does not exist because you have a vertical asymptote here. So as x approaches 0 from the left, we get closer and closer to what? What's happening? As x gets closer to 0 from the left, this approaches what?
It's closer to 0
What does this arrow mean? It's going where?
Negative.
It's going to negative infinity, right? It's going to negative infinity. As x approaches 0 from the right, your function is approaching what? Positive infinity. It's approaching positive infinity. Good. So that brings up this idea of infinity. Okay, so let's introduce that. So notation, we will typically write plus infinity. I won't write plus infinity a lot. I'll tend to write just infinity. So this is a symbol. This is a symbol meaning increasing or getting larger without bound. Sometimes, or most of the time, you'll see me write that, like an 8 laying on the side. Okay? This means what? Negative infinity. It means decreasing or getting smaller without bound. So you have positive infinity and you have negative infinity. It's important to note that they are not numbers, right? They are not numbers. They are just symbols indicating whether your values are getting closer or getting larger without bound or getting smaller without bound. Okay? So going back to the example, 1 part 2, the limit of 1 over x as x approaches 0 from the right is infinity, or positive infinity. And the limit as x approaches 0 from the left of 1 over x is what? Good, negative infinity, because it approaches negative infinity there. What questions do you have? Yes, there's a question. Go ahead.
For part 2.
Yes.
Or example 1, question 2.
Mm-hmm.
Where just x approaches 3. The
Yes.
reason it's not infinity there is because you stop before you stop right at 3 before you have to keep going.
You're absolutely correct. The question was regarding as x approaches 3, it was asking why wasn't it not infinity? And it's because the reason you gave. 3, your function is approaching this value. So it's right here. And it doesn't go beyond that. Yes?
Along with that question, if it were saying x as x approaches 2, would it then be 1/2?
Yes, it would be. So the question was, if you're looking to find the limit of 1 over x as x approaches 2, would it be 1/2? Yes, it would be. The way your book explains it, they take values close to 1, they take values of close to 3 on either side of 3, and they do a table, which is what we're going to talk about in the next example. We're going to talk about that. But your book in this section explains it by setting up a table, taking values close to that number on the left and right to actually see the pattern that the numbers are getting closer and closer to that one specific value. But yes. What other questions do you have? Okay, good. So let's look at example 2. Let's look at example 2 here. So, given a is equal to -2, and the table of values here. So in this row, x, I've given you x values. F of x, I've given you the corresponding y values for a specific function. Notice that we're approaching -2. Notice that we're choosing values of x closer and closer to -2. From the left, closer and closer to -2 from the right. Does that make sense? Respond, please.
Yes.
Yes, okay. All right. Thank you. Got you online. Thank you. So, find the limit of f of x as x approaches a from the left. Remember, a is -2. Find the limit of f of x as x approaches a from the right. Find the limit of f of x as x approaches a. And find f of a if it is defined. Would you like a couple minutes to work on the first 2 parts?
Yeah.
Okay, go for it. So one thing to note here, I'm going to move this down. In order for, so a fact, the limit of f of x as x approaches a exists if and only if the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left. Okay? All right. Go ahead and take a few minutes and work on A through D. So, in part A, I asked you to find the limit of f of x as x approaches -2 from the left. As x is getting closer and closer to -2 from the left-hand side, the values are doing what? Can't hear you? Getting smaller. So what would this be equal to here? Can't hear you. Talk loud. Be confident. Yes, negative infinity. Negative infinity, that's correct. That's correct. Right? Because they're getting smaller exponentially. It goes from -1 to -11, from -11 to -111, and then it goes to -1111. Of course, we have the 0.12s here. Okay? As x approaches a, or -2, from the right, what is happening with the values? They're getting closer and closer to 0. Very good. Notice that these values are getting, as x gets closer and closer to -2 from the right-hand side, these values are approaching 0. So that's equal to 0. What's the limit of f of x as x approaches a? It does not exist. Very good. It does not exist. Why? Very good. Because the left-hand limit, and I'll define that in a minute, the left-hand limit is approaching negative infinity. The right-hand limit is approaching 0. Good. So the reasoning why this does not exist is since the limit of f of x as x approaches a from the left does not equal the limit of f of x as x approaches a from the right. And instead of a, of course, you can write -2 because that's what we're looking at here. What is f of a? Can you tell me what that is? No, you can't tell me, which means it is what? Undefined. Very good. It is undefined. It's undefined since there is no value. For f of -2. Okay? What questions do you have? Okay? The limit of f of x as x approaches a from the left and the limit of f of x as x approaches a from the right are called one-sided limits. They're called one-sided limits. Okay, and a fact here, couple of facts. If the limit of f of x as x approaches a from the left equals the limit of f of x as x approaches a from the right, then we say that the limit of f of x as x approaches a exists. Okay? If the limit of f of x as x approaches a from the left is not equal to the limit of f of x as x approaches a from the right, then we say that the limit of f of x as x approaches a does not exist. Okay? For the next example, you will need your calculators. For the next example, you will need your calculators. Feel free to use your calculator on your phone if you wish. Okay? So here, you need to estimate the given limit numerically if it exists. If it exists. So, I've given you the function x squared plus 2x plus 1 divided by x plus 1. And I want you to find the limit as x approaches -1 of that function. So this is your f of x here. So in order to find that, notice that if you substitute -1 in, your denominator is what? 0. We cannot divide by 0, right? Which means it's undefined there. However, the whole point of this section is to provide the intuition as to why a limit can still exist for this particular function. You find that out by examining values of x close to -1, but not necessarily equal to it. That's going back to the definition where it says arbitrarily close to, but not necessarily equal to. So you can get close to it on both sides, but not necessarily equal to it. So find the corresponding f of x values for the x values I've given you on the table and determine what this limit is going to be. Find out what that's going to be. Go ahead and take a few minutes and do that. So for example 3, what did you get as the limit as x approaches -1 of f of x? What did you get? What was that equal to? Not everybody at once. What was that equal to? Yes?
I got that it doesn't exist.
You got that it doesn't exist? Let's see. Let's check. So whenever you substituted in -1.1, what did you get for f of x? -0.1. Good. You can continue telling me the values so I can fill in the table. Go ahead. Yes, anyone. If you want it, jump in. Go for it. -1, when x is -1.01, what do you get? -0.01, good. When x is -1.001, what do you get? She says she's done. Somebody else jump in.
-0.0001.
Good. What do you get when x is -1.0001? Good. Let's make that a little bit better. Let's make it all fit there. Negative 0.0001. Okay, and then we skip negative 1 because we know we cannot substitute that in directly. Whenever you have x is negative 0.9999, what do you get? 0.0, say it again.
0001.
Good. 0.0001. Whenever you have negative 0.999, what do you get?
0.001.
0.001. Good. Why am I putting my 1 so close to the 0? I have no idea. Okay, and then redo that. When you have x is negative 0.99, what do you get? 0.01. Good. And when x is negative 0.9, what do you get? 0.1. Good. So notice that your values on the right side are, as x approaches negative 1, from the right, your values of f of x are getting closer to what value? 0. As x approaches negative 1 from the left, your values are getting closer to what? 0. So what does that mean? This is equal to? 0. Good. That's equal to 0. So because your left-hand limit and your right-hand limit are the same, they both approach 0, that means that your limit is 0. Okay? All right. So now in example 4, let's estimate the given limit numerically if it exists. We have the limit of 6x squared plus 5x plus 100 divided by 3x squared minus 9 as x approaches positive infinity. So here we want to choose values of x that are getting larger without bounds. So we'll do 10, 100, let's leave a little bit more space, 1,000, 10,000, and then 100,000. So when we substitute those x values in, what do you get for f of x whenever x is 10? 2.5773. Okay. What do you get when x is 100? 2.02? 0.61. Let's do it the same. Or 0.6. When x is 1,000? When x is 1,000? Okay, when x is 1,000, what do you get? Okay. What's the other ones? 2.0017. Good. When x is 10,000, what do you get?
2.0000.
No, 2.000167. Okay, good. And then whenever x is 100,000, what do you get? You get what? Not 2.
It's
Almost 2. So 2.00002. Good. So what's happening with these values, these f of x values, x gets larger and larger. What are these f of x values approaching? 2. So what does that mean about this limit? The limit of this function as x approaches positive infinity is 2. Very good. Notice, just an observation, notice that if you look at this function, if you look at the leading coefficients, that's 6 divided by 3 is what? 2. It's not a coincidence. If these polynomials, and you'll learn this in section 3, if these polynomials in the numerator and the denominator have the same degree, you will take the leading coefficients and divide them. and that will be your limit. Only works if they have the same degree. Okay? And it only works whenever you're actually looking at infinite limits. Okay? So, oh, random mark. I'm just moving the screen up. Okay? So, this means what? I've said it a few times. What does this mean? Read it. This is read as, or it means what?
X approaches positive infinity.
Good. Very good. X approaches positive infinity, or X approaches infinity. So in other words, X gets large. X gets large. What does the next one mean?
X approaches
Good. Good, both of you. One in class and one online. Good. X approaches negative infinity. So that means that X is getting large negative, or it's getting very small. Okay? All right. So in the next example, example 5, I see people still writing, so I'll give you a minute. Just look up when you have it. Okay? So in the next example, we need to use the graph to compute the quantities. We need to use the graph to compute the quantities. So I've given you a function, f of x. It's so. Now let's evaluate all of the limits here. Would you like a minute to try it, or you just want to work on this together? Sure, and then the next one you can work on. So the limit of f of x, as x approaches 3, let's see, as x approaches 3, we're out here, right? So as x is approaching 3, our function, if this is 3, let's mark it. So if that's 3, as x approaches 3, our function is approaching what? If this is a closed circle here, 1, right? It's approaching 1. Good. So let me make this like that, right? It's approaching 1. So that's 1 here. B, what's the limit of f of x as x approaches 1 from the right? Okay, thanks for being patient. So as x approaches 1 from the right side, our function is approaching -1. So we get -1 here. As x approaches 1 from the left, notice that x is getting closer, but from the left-hand side, our function is approaching what? -1. So what is the limit of f of x as x approaches 1? Equal to? Can't hear you? -1. Good. Why? Very good. Because they're both approaching -1, meaning the left-hand limit and the right-hand limit as x approaches 1, they're both equal to -1, so that means that the limit of f of x as x approaches 1 is equal to -1. What is f of 1? So we go to 1. What's f of 1? 1. Very good, because that's where your closed circle is at. Very good. Okay? And then, if we then indicate this is the rest of our graph, what is the limit of f of x as x approaches positive infinity? So as x gets larger and larger, our function is doing what? Yes, so it's approaching infinity. Good. It's approaching infinity. You got it. What questions do you have? Okay, so now take a minute and do A through F for example 6. Use the graph to compute the quantities. You all, good discussion. Okay. Okay, let's go through this. Very good discussions. let's go ahead and talk about parts A through F. So, we had to find the limit of f of x as x approaches 0 from the left. As x approaches 0 from the left, our function is approaching what? Infinity. Good for you. As x is approaching 1 from the right, our function is approaching what? 0. Good.
So would you explain that again?
Yes, absolutely. You want me to use different colors?
For A, no, you're fine.
Okay, so as x approaches 1 from the right-hand side, you follow your function. Your function is getting closer to 0. Your y value is getting closer to 0 as your x value gets closer to 1, but from the right-hand side.
Okay, I got D&E.
You got what? D and E?
Yeah.
Why? Why did you say D and E?
Because I wasn't focused on the one coming from like the negatives, like negative 0 coming from the right to the left. I was focusing on the top, like the top of the y-axis, like in that, where how it
But-
would never touch 0.
But this part is coming as this is as x is approaching it from the left hand. And even from the left, it's equal to what?
Okay.
Even from the left, as x approaches 1 from the left, your function is still approaching what? 0. It's still approaching 0.
Okay, thank you.
You're welcome. So you get 0 here. What is the limit of f of x as x approaches 0? What is that? As x approaches 0, it's positive infinity. Good. It's positive infinity. Notice that as x approaches 0 from the right, your function goes to infinity. As x approaches 0 from the left, your function goes to infinity. They're the same, so you get infinity. What's the limit of f of x as x approaches 1? 0. And it's 0 because the left-hand limit as x approaches 1 from the left, that's equal to 0. And we saw in B that that was 0. So because the left and right-hand limit of 1 is equal to 0, that means the limit of f of x as x approaches 1 is 0. Does that make sense?
Yeah.
Okay. What is f of 0? 0, because that's where your closed circle is. So if you're at 0, you substitute 0 in, hey, you get 0. What is f of 1? That's really a 1 right there. That's really a 1. I switched my 1s up. I should write my 1s like that for the sake of the graphs. But I'm glad you got used to my notation with my 1s. So that's a good sign. Thank you. This is technically a 1 here. So f of 1 would be equal to 1 where your closed circle is at. Does that make sense?
Yes.
All right. Have a wonderful weekend. See you on Tuesday. 10.2 and 10.3 videos will be posted. Make sure you watch those before class and come to class with questions, okay?
Thank you, Dr. Lewis.
You're welcome.